Hi, everyone. Thanks for coming. My name is Ben Royce. I'll be moderating today's panel. I'd like our panelists to come and join me if you can. And we will start with some tough questions around AI and building AI-first products. You guys want to come up? All right. So joining us today, we have quite the list of heavy hitters, I would say. Joining us from Google here, from your right to left, Burak Gokturk, our GM of Cloud AI at Google, Google Cloud specifically. We have Marty Brodbeck, our CTO of Priceline. And in the middle here, we have Vish Anantraman from the Mayo Clinic CTO. So thank you guys for joining us. I appreciate it.
Thanks for having us.
So I think it's actually I want to make this as conversational as possible because I think you get the most value, you get the most understanding, and the most directness when you keep it, I'd say, informal. But a couple things I want to cover today is a little bit around AI, building first, data, and then I want to spend quite a bit of time on generative AI, which is the word du jour, or the phrase du jour, I would say. So with that, I'll start asking a couple questions. Building AI-first products. Many of our customers, cloud customers, ask us the best way to get involved with AI. And you've heard it, you're talking about it. Doing it, a little different, a little harder than just talking about it, right? How do you suggest they get started, and what do they choose for their first use case? I'll look at maybe Vish. Maybe we'll start there.
Yeah, I mean, I think there are plenty of use cases. And at Mayo Clinic, as a health system, we have administrative use cases, we have clinical use cases, we have operational use cases. And the best way initially to get started is to understand where your data is most accessible. Because it's almost, you can have a lot of problems to solve, and you can solve many areas. But if we start to identify where are the areas that you have data easily accessible, and we spent a lot of time initially to try over the last several years in our partnership with Google to bring data together in a place that is easily usable for AI. Because what we learned is you can do a lot of smaller models and you can build a lot of areas which may potentially have very high value. But if you cannot operationalize that, you can't see the value of that AI very, very quickly. So I would say think about areas where your data is much more easily accessible, where applying a model can provide operational benefits in a reasonably quick time. So for instance, if you have a data set that takes, it can only be brought in every night, but your operational decision making has to be done in an hourly basis, then you're trying to figure out how you build this great model, but you don't know how to operationalize it.
Well, you're in healthcare, so operationalization is, it could be in an operation, literally, right, in that case. How do you reduce the time to value in that place?
Yeah, I think healthcare has obviously got a lot of data that is streaming data from devices, from our electronic health records, from our lab systems, from our radiology system, imaging systems, and so on. Traditionally, it has been very difficult to build models on streaming data. And so what we would build models that, I'll give you a pragmatic example. You want to predict if this patient who's in the hospital is getting discharged in the next day or two. It's called predicting the length of stay of how long the patient's in the hospital. Because every additional day for a hospital, most hospitals in the United States, cost about $4,000 to $5,000 for the hospital because they are paid for the whole episode in general, not for the number of days, not like a hotel, right? And very often, predicting that was seen as very, very valuable. But then as we started building those models, it became clear to have that model be operational, you have to have the data be refreshed every 2 hours, every 3 hours. And traditional systems were built to do data analytics on overnight data. And so to get value, what we started to do was to bring this data into more real-time streams and make it accessible in a single pane of glass. And we use BigQuery for everything. Now you have data streaming into BigQuery, and you have data models that were trained on BigQuery but can also be executed on BigQuery.
Interesting. What was your first foray into AI? What was the first AI use case? And this is for all of
you. We've looked at what use cases are going to have the biggest impact on our customer experience. And so, we have this vision of providing really personalized and tailored travel products based on real-time signals that we're getting from customers. So we looked at, from a generative AI use case perspective, the parts or sets of features that we're going to provide that personalized experience for our customers. So we looked at anything from personalized hotel reviews based on the type of customer coming into our platform, to providing neighborhood descriptions based on the hotels that they would be visiting and the type of customer it was, whether it's a single traveler or a family of four. So we really honed in on use cases that were going to provide a much more personalized, enriched user experience. And a lot of what made those use cases impactful is that we had a very rich real-time data infrastructure built out already. So in enabling those use cases was much easier because we had a customer data platform running in BigQuery. We were getting real-time signals from our e-commerce platform via Kafka being processed into Dataproc. So for us, again, we tried to focus on where generative AI and AI was going to have the biggest impact for our customers.
So you would personalize like a neighborhood description based on someone who,
Correct.
25 years old, loves nightlife.
A great example is something as simple as a hotel description could have multiple meanings to a person based on how they're traveling and when they're traveling and the size of the party that's traveling with them. Sure. So generative AI gives us the ability to personalize every fine detail of the product page for us in a way that can resonate with the consumer based on their experience and how they want to travel for that particular trip.
Yeah. Burak, what was your first foray into AI?
Maybe I'll give actually a personal example because this will tell us about how long we've come along.
Yeah.
This is also almost 30 years ago. My first experience with AI was essentially doing quality detection for principal circuit boards, like TCBs, or these are the boards that you see in electrical system.
Semiconductor
yes,
boards.
Yes. Yeah. Nowadays they're like very small. At the time it was like big.
Yeah.
So we've come along a lot on that as well. And then shortly after doing various shape modeling using AI for actually detecting various types of cancers from computer tomography images like colon cancer, liver cancer, etc. And I think one thing that was common at the time is you would design your AI very specific to your, whatever you're trying to build, from all the way the exact design of the algorithms, to the training set, etc. It's almost start from scratch every single time. And I think with generative AI, that's probably the biggest change that we're seeing, because lots of AI tasks, you can actually start with almost no data. I would say it's such a breakthrough, and it's so nice to see this transform.
We see so many use cases in healthcare specifically. It seems to be because some of the devices are relatively standardized, like imagery, for example, and radiology, which makes it actually more accurate. Just tell us about the AI factory. I mean, you have multiple models at work at the Mayo Clinic.
Yeah, no, I mean, so Mayo obviously provides a lot of complex healthcare for many advanced conditions, and the patients that we typically get are extremely complex patients, and we have a ton of data accessible for these patients. We're also an academic medical center, and we have we spend about $1 billion in extramural research through the NIH and other places. So we have about, our challenge was, from a technology perspective, to provide tooling and data accessible to thousands of researchers. It's not one or two,
right,
but literally thousands, in a secure way, in a privacy-protecting way in many cases, because we are dealing with patient identifiable data, and to be able to also provide some of the best and latest, greatest tools available. And because they are by nature researchers who want to publish as well. At the same time, patient safety and making this accessible is very critical. So what we did was we took the Vertex AI platform, but started to build our own customization layers around it from a data security perspective, from how do we make it really simple and easy for a user to be able to connect to the data in our big lake. And so, for instance, we at Mayo Clinic have about 30 petabytes of imaging data in the Google Cloud. We use an industry standard format called DICOM, But most of the AI research or AI models are built, you can't use DICOM out of the box, and you have to use various libraries to process that DICOM into JPEG files and other formats that make it much more easier for the tensors to work. And so we built all these playbooks, and that's what we call as AI Factory, which allows us to connect to this data in a reasonably simple way, so that a researcher can spend more time in doing AI work than the data engineering work, for example. And so we also built something called the longitudinal patient record, which brings in data from across all of our modalities, whether it's genomic data, whether it's structured data, unstructured data, and imaging data, and said, well, you can access all of this in a single pane of glass using the Google tools. Like we started off with user-managed notebooks about 3 years ago, and then we heard from customers that sometimes controlling costs with these are difficult. So we standardized most of it to say your happy path is going to be using a managed notebook. And very excited about Colab Enterprise now, but managed notebook meant that they could just use it when they want. It'll shut down when they didn't want it. And suddenly we saw a lot more adoption. So we've taken this approach of a product-centric mindset to taking the tooling that's available, the data sets that are available, and offering some nice pathways for our researchers.
That's great. I mean, in healthcare, the stakes are high. I think in travel and bookings, it's incredibly competitive. Like, excellence is kind of the bare minimum, I'd probably say. Is that fair to say? I love talking about use cases because I think the technology is cool, but how it gets used, I'm always fascinated by it. What are some of the best AI use cases? And I love learning from this. What are some of the worst AI use cases?
Yeah, so some of the what I would say the coolest use cases are really around, from our perspective, building an end-to-end customer journey, or what we call the connected trip for our consumers. And it's really taking our product like a hotel and connecting the user from the ability to search, to price, and to book a product on our platform. So for instance, when you go onto our product details page, you get 5 or 6 capabilities that will be powered by generative AI, whether it's the personalized hotel reviews, the personalized neighborhood descriptions, the back-end checkout process that we run through our sets of capabilities. But underneath all of that is really the capabilities to use LangChain to chain together these different generative AI capabilities, from the hotel product to the review of that product to the description of that product. And rather than all of that content being static, it gets updated in real time based on what's happening in the world. And then the power of taking LangChain, you're able to connect your generative AI models with authoritative sources of data like Google Maps or the Places API to create an ecosystem where the product is completely tailored based on the user logging in and the signals that you get from that user.
I mean, that makes sense. Everyone talks about a property like a hotel, but everyone has different experiences by definition, right?
A hotel is a multifaceted that depending on who you are and why you're traveling, you can surface different facets of that hotel that will appeal to that individual user than just saying, well, this is the St. Regis Hotel or the Hampton Inn. You can really tailor and personalize all the content around that property based on the user.
I want them ranked by high Wi-Fi speed. I want them ranked by Wi-Fi speed. That's like my number one.
We'll be able to do that.
Yeah, really? Amazing. That makes I will put up with a worse hotel if the Wi-Fi is amazing. Cool. All right, let's move on. Or I was going to say, Burak, best and worst use case.
We're hearing lots of use cases right now.
Yeah.
I think all the customers are trying different use cases. Some are trying classification, some sort of generation use case, some of them summarization, lots of chat and conversation use cases. Search is at the core of almost all of these use cases as well. And I think maybe the harder part of the question is what is to avoid. I think at Google, we are paying a lot of attention to ethical AI, responsible AI, all the safety filters, safety scores. And we're particularly careful about any AI application that could create a bias as well. And I think we're trying to educate both internally ourselves as well as externally the world as well on some of these use cases and applications. And I think when it comes to generative AI, lots of safety scores for different attributes are being provided as well, so that you can design your final application using those safety scores as well.
I saw a fun use case where it takes a large language model to analyze the question being asked of a large language model to see if it was even appropriate, for work or in the enterprise or whatever, which is kind of fun. So we're seeing AI for AI.
Well, I was going to say that, I think if you'd asked this question 6 months ago, I would have rattled out a whole set of things what you shouldn't use AI for, right? And particularly analytics use cases, what are really more analytic use cases and so on. Regular expressions can do a great job. But I think, we think of generative AI really as a Promethean moment, right? And I'm not the first person to say that. I'm not going to be the last person to say it.
Right.
And that has changed the game in terms of what you think about AI. And I started my journey in AI building rule-based systems for sub-Saharan Africa healthcare workers there, trying to provide them WHO guidelines. It was a rules-based system, and that was AI, right? And now you have, as someone said, from 10 million programmers, you've had now anybody that speaks a language becomes an AI programmer. And if you can make that generative AI technology affordable and safe, free of biases, I think the kinds of use cases, there's no more going to be, I'm hopeful in the next couple of years, you're not going to ask that question ever again.
Yeah.
I think the biggest misnomer, though, is generative AI software development is no different than traditional software development in the sense that it takes a very iterative and A/B testing approach to get the optimal results. So people ask me a lot of times, so you've developed, generative AI, you put it into production, what's next? It's continuous and constant iteration and testing, because the biggest thing that we've seen anyway is user intent is something that's a learned behavior over time.
Yes.
And the only way that it gets better is by the consumption of more and more training and learning data. So that means more consumers interacting with that feature and learning the intent of consumers. So for us, it in certain cases, it could take us 25 iterations of a generative AI feature to put it into production. And that's just constant A/B testing in order to get to 100% of customer traffic.
So I've had to remind people that they're called developers for a reason, because it develops. It's not one and done, right? Yeah. That's actually where
In our case, there are two approaches, right? One is we call big AI and the other is small AI to some extent, right? The big AIs are, we're going to diagnose something, or you're going to, where you need a high level of specificity and sensitivity, and you need to really be accurate, may even go into FDA approval cycles and so on. And then there's small AI, which is, can I automate the front desk in a doctor's office, where the tolerance for error may be much lower, but we try to use some existing out-of-the-box solutions, whether it's from vendors or others, but we want to bring AI in many places. And it's not always just, you need to be 100% because you may not get 100%.
All right, let's talk about the training data, because a lot of the success of these things depends on the data that goes in. I think we mentioned, for example, foundational models bring a lot of the data up front. When you need something, let's say non-generative AI, what do you look for in a training set? What are potholes? What are things you love to see? What's the golden ticket when it comes to, because data is small word means a lot, right?
So training data for us, particularly with these features, is real-time event data that we're getting from consumers or customers. And we store that information in a series of logs that then our product teams and engineering teams iterate on in the next sprint cycle. So for us, for a lot of the features and functions that we're building generative AI for, because they are customer-facing, the training data is really the live information that we're getting through customers and their interaction with the features and functions of the product. The other thing is the signaling data for us, particularly because we're a consumer-faced platform, is really built upon a customer data platform where we store all the search, pricing, and checkout information that our consumers are doing on our platform. And that becomes another really good training set of data in terms of how we personalize our products and the feedback that we get.
That's great.
I can mention one thing about, again, I'll tie it to generative AI as well.
Sure.
We see lots of customers who actually have data, and maybe lots of it, but one of the challenges is that it might need to be labeled. And they might have only limited capacity in terms of both expertise and just being able to reach to humans, human experts, to be able to label them. I think one trend that we will continue to see is that lots of customers will actually end up using generative AI or larger models, which are so much better in general in reasoning. Like the larger the model, much better in reasoning, to actually be able to label some of that data, maybe at least as candidates to human experts, because there are just not enough human experts in the world to be able to label all the data out there. And I think generative AI will help with that as well.
Yeah, labeling a cat and dog, we can do that. But you say, hey, is this, like I've seen labels on some data where it's, you have to explain the emotional thing, or you have to explain the situation. And it's like, that is not easily done without explicit experts being like, that is, that is a presentation versus that is a speech versus that is a meeting.
And you would be surprised, even for labeling cat and dog kind of examples, that there are just not enough people in the world to do it, or that will be excited enough to do like those tasks as well. Like, I think
it gets boring. Actually, had
customers are having challenges with that.
I had a guy on a meeting once. My cat is like brown with black stripes, and a guy walked behind the camera, and this guy goes, Ben, there's a raccoon behind you. I was like, that's my cat. So humans get it wrong too. Cool. Let's talk about new features. You got a model, you've trained it, your narrow use case is working well, right? You want to add new features, you want to add new parts to it. How do you roll it out? I imagine in healthcare, this is carefully done, I hope.
Yeah, I mean, I think, we have, when we think about anything that is going into clinical practice, we just think about it like we would treat any other clinical trial, frankly. And so we take the approach of, we do the measurements, we measure and see what's the efficacy of the model, what is the sensitivity, the specificity, the ROC, and some of it may reach a point which needs an FDA approval. Not everything in healthcare needs an FDA approval, and we have an elaborate process and in fact a dedicated team that looks at software as a medical device. But there's a determination made early on as we bring in new features to say, well, is this a software as a medical device, or this is more of a diagnostic aid, which doesn't meet the bar of an FDA approval type of scenario. But even in those, generative AI is a great example. We're working on some very interesting use cases on low risk for the patient, or for the provider, but potentially high value in reducing administrative burden and loads, right?
Yeah, in healthcare, there's like a whole, they call it alarm fatigue, I think it's called.
Yeah.
And it's like basically there's so many devices that are being cautious that they get overloaded with alarms, which means, when everything's an alarm, nothing's an alarm. Is that
right? You just have too many red lights there. You don't know what to do. And so, and the problem with something like generative AI in this case is you don't know. In some cases, the green is actually bad and the red is actually good. So you have to think about it. It's like golf scores, right? And there's continuous parameters. What may be normal for patient one is not normal for another patient. And so there's a lot of consideration, and the approach that we've been taking is just think about it like a scientific process when it comes to diagnosis and cures or anything in the clinical practice. But that's why I think of the other one, which is small AI, where we can do a lot more from a patient satisfaction perspective. We all have been to a doctor's office. No one likes the experience. We still have to digitize a lot of things, but I think AI can have a significant and faster impact in those areas as well.
I feel your pain. I worked at Pfizer for a long time, so I can understand the process and the validation and the care in which you have to monitor and manage patient information. Luckily, I work now in an industry where we're not dealing with patient information, so
much less like regular.
Yeah, so our approach is, particularly with generative AI, we've taken the approach of failing fast. So, like software development, the generative AI features, we've taken a very agile method approach to it, where we'll design, develop, and deploy a generative AI API. We will treat that pipeline like a software pipeline, similar to CI/CD. We'll try to create repeatable patterns for the particular use cases that we're going to implement so that they become declarative over time. And we A/B test all the features to find out what are winners. And we have a method in which we measure those features, which we call NIPBD, which is really around how much additional operational efficiency or revenue is generated by this new feature and how it impacts the customer. And so that's how we gauge if a feature will go to 100% live and be a full-fledged feature on our platform, or we'll shut it down and then we'll move on to the next one.
What about like a random percentage of users? Would that happen?
No, we're pretty strict in how we do A/B testing.
Okay.
So we'll take 25, 50, 75% of the traffic and we'll A/B test it against the feature that's currently in production, and we'll monitor to see if that feature has a positive or negative impact on our platform.
Yeah, I was going to say, I use your website to rank hotels all the time, so thank you for that.
Yeah.
It's made my life so much better. Okay, cool. So let's say you've got your model running, you've got it trained, you're happy with your data, you've got a couple new features, you've rolled them out, some worked, some didn't, fine. Adoption, not necessarily user adoption, but maybe internal adoption. How do you get people, maybe employees, or I guess users, to adopt it? And when you run into adoption, like maybe it works technically, but it's not successfully used. What's the first question you ask? How do you approach this problem?
Well, from our view, there's two parts of what I would say the generative AI architecture. There's the back-end architecture that is really powered by generative AI Studio and products like Vertex, where you're really creating the machine learning CI/CD pipeline to create APIs that can get consumed on the front end.
Gotcha.
So the first is really educating our back-end engineers to be best-in-class data engineers to create repeatable pipelines of generative AI APIs. The second piece, which is probably the higher learning curve, is teaching your front-end engineers to be really good prompt engineers. And to have them walk through the development cycle of creating compelling prompts that drive conversion. You could have outstanding generative AI capabilities on the back end. But if your prompts aren't very good, you're not going to get any conversion on your platform. So that's why it's very important that you're capturing real-time eventing data from your customers, understanding what their intent is, and then taking an iterative approach to improving your prompts.
Is it like years of experience research to get that question, or is it intuitive?
I think it's a combination of how you design and develop products within your company. For us, there's a ton of discipline around product management, product research, and the way in which the engineering and product management teams engage to develop those prompts.
Got it.
So,
Go ahead. No, please. Well, I was going to take a very different angle on adoption. For us, adoption here is our customers' adoption.
Sure.
In our case, it's doctors, it's nurses,
Right.
it's patients. And traditionally, and I think this is going to be the same thing with generative AI, is any new feature is just in yet another widget, right? And my doctors keep saying, well, I already have 25 widgets on my screen. You put in a 26th widget, well, why should I go there? And I think we have to pay really close attention, and I'm not saying anybody has really solved this really well, but we have to pay close attention to what value is it providing, and why should they adopt this? And if we can even solve 2 or 3, well, that's the one reason I'm absolutely going to go and do. There was a product we built some time back. We called it the parking lot app for the doctor. They would come in the morning because they're going to do rounds on 15 patients. And usually the resident is providing some summaries for them, but we said, well, what if I gave you a summary of what's happened to your 5 patients of interest overnight in just this email summary?
Yeah.
Right? And it's AI, it's kind of a recommendation engine. And that was great. And the only way to deliver it is through this AI chatbot. But then you got them hooked onto one thing that is now going to bring them back over and over again. So just like we think of any other product, we have to think very closely about what's that hook that you're going to bring them in. Because otherwise you'd be building all these great features and no one's ever going to use it. It's a real worry.
Right.
So all of your questions actually, both feature iteration, adoption, I think a lesson that we should take is have your data ready to evaluate against. So as you iterate, as you apply AI, what is your golden set? We call it golden set times, golden training set. And this way, as you iterate, you can see, and this could be A/B, this could be other means. Everyone has a different means of being able to have a golden set and evaluate against that. And this way you can say, okay, here is how much it improved. And in some cases it will not. It's also important to be able to fail quickly as well. And also when it comes to adoption, when you have data, it's just so much easier to convince anyone, right? So it helps with that as well.
That's I've seen some adoptions where they added a new feature and it made the model worse, but people liked using it more. And I was like, that's a decision you have to make, I guess, at that point. I want to make sure we have enough time to talk about. We've talked a little bit about generative AI. I want to make sure we talk because it's no question it's the buzzword du jour. I gave a talk in May of 2022 on generative AI, and only 2 people showed up. I gave the exact same talk like 8 months later, and there was 1,000 people. I mean, it's like the rise of this has been astronomical. And I'd say like generative AI was the 4th section of AI that kind of was lagging, and then all of a sudden now it's skyrocketed to the top, which is super fun to watch. This is for you, Burak. How has generative AI changed the AI world?
Yeah. And I think we talked a little bit about it, but I'll mention maybe 2 important aspects. First of all of you, lots of the customers here, they all came to us and wanted to do AI several years ago as well.
Yeah.
It was just that at the time, you really needed lots of AI expertise, data scientists, machine learning engineers in your teams. And I think one thing that generative AI really changed is that now everyone literally can build AI applications.
Relatively easily.
Relatively easily as well. From AI practitioners to developers to business users as well. Like literally everybody in the universe. So I think that's one big change. And the second one is the training data. It used to be that you need to figure out what your training data is, you need to collect training data, you need to label that. I think most of that is much more minimized right now with generative AI as well. So when you combine the two of these, all of a sudden the pace of innovation, the desire was already there, but the pace of innovation now is just
You're talking about the foundation model. So basically do most of the data for you.
Yes,
right? And then,
absolutely. You might still need to tune it with additional data, but it's nowhere in comparison to what you had to do before.
Coding was great. I learned how to code in college, and I did it for years. And then, in the last few years, it wasn't my job to do that anymore, and I sort of fell off. And then Cody came out, and I was like, I'm back. It was like I came right back. It was so much fun, kind of get back into it. So, Vish, Marty, what do you think? How is generative AI changing AI?
I think it's basically democratized the ability to do machine learning and AI. I started my career off as a C++ programmer designing, equity arbitrage and programmatic trading. And so we had a team of 50 data scientists that all we did was design and develop the algorithm for arbitraging stocks and doing program trading. Now you would probably need 5 people to do that. Totally. And so it's really democratized the ability for these things to get adopted across the enterprise. I don't think in 5 years we're going to be talking about generative AI anymore. It's just going to be another method for how we do software development.
It's just we need the AI, and we'll just kind of almost assume it's part of the process.
But I think, so I'll give you what happened at Mayo Clinic. What we decided is, we really want to see what this can be done. And so about 2 weeks ago, we announced a request for applications across our enterprise and said, anyone who has an idea, write up a 2-pager, and we'll fund a POC. And within 2 weeks, we've had about 350 different teams. Half of them are not, 3/4 of them have never done programming before. To talk about democratization, what generative AI has done is really spark that interest that people have seen, are able to see. They can log on to Bard or ChatGPT or whatever they want and see what it can do for them. Right? And so now they have immediately the ability to identify an unmet need that previously you never thought, who's going to solve this problem? Because, we have enterprise priorities, and the big priorities are building, diagnostic systems. But suddenly, I think it has opened up a flurry of ideas, and we'll have to see how we can execute on all of those, but it's just opened up that thinking that everybody can solve problems.
I mean, everyone's talking about the large language models. They're getting larger and they're huge, I guess now. Gigantic is probably the word we should use. What have you guys learned from these large language models? It's a little different way of doing AI, right? We've always had the training data, like you were saying, label it, train it, and go from there. Now you get handed basically a pre-trained model and you sprinkle your smarts on top is probably the lightest way to say it. What have you learned from large language models? What interests you? What?
I think two real critical points is we've taken a trust but verify approach with the large language models. They hallucinate. And so, really doing iterative development and marrying them with authoritative sources of data that can actually train the large language model around accuracy has been important. Hence, I was talking about before where we use an approach of lang chaining together large language models with authoritative sources of location and placement data has been critical for us to get hallucinations way down. And then I think the second big thing is really around the prompt engineering pieces. Yeah. And listen, the lesson that we learned is you cannot just put in generative AI and think everything is going to work correctly. It's really built on a foundation of having very good data so that your prompt engineering is accurate enough to use the large language model, but also use authoritative sources of data to get to the right outcome for your customers.
And I think your question was a very good question in terms of it's not about generative AI, it's about language models, right?
Right,
and so they're two different things, and it's not all about generative models. And the analogy I use is, if you just had a big chip and the CPU, and you didn't have power for the CPU, or you didn't have a GPU to run your games back in 15 years ago, well, your computer was pretty useless. And so you have to think about this, and that's our learning. You have to think about this as an ecosystem of data, of tools like LangChain and others. I'm excited about the Vertex extensions, and models, not just one large model, but many separate individual models that can together provide awesome solutions.
Okay, but the CD-ROM tray when the computer was off was definitely a couple. Definitely a couple. It was for a while there in the 90s. Burak?
I think both Marty and Vish really touched on really important points. You need to really combine large language models with I would actually call it directly search. Accessing, factual, fresh data at the same time. Like I wouldn't, and through extensions, through other means of search or accessing data as well. But I wouldn't undermine that. I would actually, even while you're starting, okay, where is my source of truth? Which data I need to search through? Do I need to use some sort of search solution for that? Do I need to use an extension for that? Do you need to search the web? I think these are things that you probably need to ask, because for many applications, summarization, conversation chats, we're hearing this is the number one thing. Okay, sometimes it hallucinates, and even when it hallucinates, it's very confident, right? So I think combining with search, think about it on day one.
Absolutely.
And then I think you'll be much more successful in your application.
We did a project with a division of the military, and the large language model kept thinking that Roger was a person. But in the military, Roger's it's not a person. It's Roger that. Roger's not involved. And we actually, once we fine-tuned the data, it actually the model learned that Roger is not a guy. It's just a confirmation. That's important in the military. You don't want to mistranscribe that, right?
That's why it's so important to have really good data assets internally.
Right.
Because the large language model, it's based upon what it knows of the internet. Mm-hmm. It's not necessarily trained out of the box on your own data sets.
Yeah, Roger's on the internet, for sure.
Internet 6 months, 9 months, a year ago, right? So even that is...
it's static.
Yeah, exactly.
I agree. I think retrieval augmented generation is something we are really doubling down on, because that's how you ground your answers.
Marty, you mentioned the connected trip.
Yes.
I don't know what that means. Explain that.
The connected trip is the ability for an individual consumer to be directly tied with the product they bought, from the search experience to the pricing experience to the booking experience to the post-booking experience. So providing a platform that gives a customer a complete view into their booking and post-booking activities. And being able to send signals to that customer during that process that creates a better experience for them. So if I'm currently on a trip to Italy, sending a signal to a consumer about a potential restaurant that's close to their hotel, or an activity that they may want to purchase for their kids while they're on vacation, or up the path, it's recommending prices based on user preference, whether I'm traveling with 4 kids or by myself, and personalizing that experience in a way that meets the needs of the consumer at that given moment.
Got it. Wow, that's complex. There's a lot of models in there.
Yes, there's a lot of models, a lot of work to be done.
We only have a few minutes, so I want to make sure we get into how you actually achieved this Gen AI thing. So did you just let your developers or all your employees run wild? Did you set up a center of excellence? Was it a SWAT team? Was it a hackathon? What was the method you got up and running?
I think it was a top-down and a bottoms-up approach.
Okay.
We have a fantastic CEO who gets technology in a way where he was driving our leadership team to embrace and take on generative AI. At the same time, we had a hackathon where we had our entire development community coming up with hacks, but they were hacks that were geared towards themes for providing a better experience for our consumers.
Like a mission-oriented almost?
Yeah, it was basically, we had a contest around, what category was, the best generative AI hack for consumer experience. And so we had a whole host of teams that participated in that. And then we actually worked very closely with our partners to really understand and learn what it really meant from a technical perspective. So all 3 of those really came together. And also Glenn Fogel, our CEO at Booking Holdings, is very passionate about this space.
Yeah.
And for us, we're really a technology company. So for us to not do anything would be irresponsible.
I hear that a lot. It's like the people, I'm not worried about people that are here at Next. I'm worried about the people who aren't even aware that this is happening. Vish?
No, I think the same thing. I think our CEO has been a big proponent. We organized an enterprise retreat about 2 months ago.
Cool.
And we made this an enterprise priority with our board of trustees. And so subsequent to that, from a technology perspective, we took an approach that we have a 3-prong approach. We first felt we needed a group of people that we call as demystifiers. These people can take this technology and quickly iterate in 2-3 days and say, do we use LangChain or do we use something else? Do we use guardrails or do we use LangChain, or how do we do? So this technology is changing so fast, you need a really set of people who are demystifiers. Then we built these small teams of 3 or 4 people who can prove that demystification can go to a POC. We call them as tiger teams. And then we use some simple frameworks. We're using Gradio or Streamlit to showcase these simple apps that can say, hey, this is what it can do for you. And now we're at the stage where we say, okay, well, let's identify a whole bunch of candidate products and then build product teams that can take this to a real solution.
Wonderful.
And one thing I hear from lots of customers is they do hackathons, as you mentioned. And I think it's a great way for lots of people to put their hands dirty and learn quickly, because they're usually time framed as well.
Yeah. Okay, I think that's all the time we have for today. I wish this had happened maybe 6 months ago. I probably would have saved everyone a lot of time on my team, so thank you very much. Let's give it a hand for our panel members.
Thank you.
Thank you, Burak, Marty, and Vish. I appreciate your time, your insight, and thank you for taking the initiative on this kind of stuff. We appreciate it.